Hi, to start today, try this question out. You've got the area of the shape is 71. Can you find the value of x and hence the perimeter of the shape? Go for it. Right, how to do this question? Well, we first need to create an equation. We know that the area is 71, so let's find the area in terms of x. So we can either split it this way into two rectangles or this way. So which is easiest to do? That's a judgment call. What shall I go with? I think I'm gonna do it the horizontal way. So that immediately gives me this blue area as x times x minus 6. And then I need to work out what this length is. And because I've got x minus 6 and x minus 2 here, that means that this must be 4. Because then if I've got x minus 6 and I add 4 on, I'll get back to x minus 2. That makes sense. And then I can work out this red area. If I add that on, it's going to be 4 lots of 15 minus x. And finally, the last little bit is I just need to set that equal to 71, and I've created an equation. You get a slightly different equation, but it would look a bit different if you split it the other way, or if you decided to do a subtraction and work out the whole area and then subtract this green bit, but they will all be equivalent. So let's stick with what I've done. Well, I'm going to stick with it. Right, let's expand it out. So x squared minus 6x plus 60 minus 4x equals 71. And we're well on our way now. Just collect terms together. X squared minus 10x minus 11 equals 0. And suddenly this has become quite a nice quadratic. It's got to be 1 and 11 in here. So it's going to be minus 11 and plus 1. So x equals 11, or minus 1, we reject the minus 1. We're not done because we want the perimeter, so we just need to now figure these bits out. So I can get rid of that 4, to be fair. I just need to replace some of these. So, okay, I've got this. This is going to become 5. This is going to be 11. This is going to be 9. This is going to be 4. And then I can work out that this is also, I had 4 before, didn't I, anyway? That's going to be 4, and that's going to be 7. So the perimeter is going to be 9 plus 11 plus 5 plus 7 plus 4 plus 4. 20, 32, 40. Actually, I could have done this a quicker way. I could have recognized that this shape has exactly the same perimeter as if I just turned it into a full rectangle, and then I would just do 11 plus 9, 20, and double it to give me the 40, but I decided to do it step by step. Okay, good start. If you did finish, then, think about how you could make your own geometrical question. We've actually looked at lots in recent lessons, such as applying Pythagoras' theorem to create a quadratic and then solve it and such like. Just make sure that's the hardest bit, creating the quadratic at this point, but just use your arguments of geometry to get the quadratic and solve it. Today, we're going to look back at simultaneous equations. This is a GCSE topic, and you normally spend quite a lot of time on it, building your way up. Today, we're just going to recap the whole thing in one lesson and bring in the aspect of A level, which is that's just slightly trickier, but it is the same kind of concept. So to start with, we're going to look back at what we call linear simultaneous equations. There's just x and y terms, and if you plotted these, you'd get a straight line. So if you're feeling up to it, have a go at sketching both of these. Well, to be able to sketch it easily, we could write it in the form y equals mx plus c. So I'm going to do the bottom one to start with. It's going to be y equals 3x minus 23. And this is all right to sketch. I know that it's going to go through, it's going to have an intercept of minus 23. It's going to look a bit like that. Okay, it's only a sketch, remember, it doesn't have to be perfect. I might add on the minus 23. I'm not going to worry about adding on this, and like solving an equation to work out the x-intercept. I just wanted the general idea. The other one is a little bit trickier because I've got a 3y, so I'm just going to make that the subject to start with. 3y is equal to minus 2x plus 8. I've decided to make it minus 2x at the front to put it in the form y equals mx plus c. So then y is equal to minus 2/3 x plus 8 over 3. I've divided through by 3. So this one is going to have a negative gradient, and it's going to go through 8 over 3. So it's going to come down a bit like this. Now, whether it goes like that or like that, I haven't really been convincing. I think it's going to do that. So I could be wrong, but all I wanted really was a sketch. Because the main point is that when we find the point of intersection, we're essentially solving a simultaneous equation. When you're asked to solve these simultaneous equations, when you first learn about this topic, you don't actually, well, probably think that it's two lines intersecting and you're finding the point of intersection, but it is helpful to know. So when we solve them, we're finding out that point here. And how do we solve them? Well, there's two ways, and so I'm going to talk about both of them. I'm going to rewrite these equations. 2x plus 3y equals 8, and 3x minus y equals 23. Okay, method 1 is called elimination. And that's when you sort of add or subtract the equations to get rid of one of the unknowns. I can't do that here. We're going straight to one of these that you can't just straight away add or subtract. So I'm going to multiply this one through by 3, I think. So 2x, I'm going to rewrite them. 2x plus 3y is equal to 8. And if I multiply this one through by 3, I'll get 9x minus 3y equals 69. Why would I want to do that? Because now I can add them together. I'm actually not going to go into loads of depth on why we can do this. Essentially, it's just because we've got, if two things are equal, that you can add and subtract the left hand, or subtract the left hand side, add or subtract the right hand side. It must be that the result is also equal. We're going to get 11x, and then the point is that these are going to now cancel. That's why I made the coefficient the same, because I add them and it cancels. That's going to leave me 77, and we're well on our way. X is going to be 7. Substitute it back in to one of the original ones. Let's put it into the second one. It doesn't matter, and if you want to be really careful, you can check. So we're going to get 3 times 7, 21, minus y is equal to 23. Quick bit of maths is going to give us that y is equal to minus 2. And that's it. Did it ask us for the point of intersection? I think it did. So really, we should just leave our answer as coordinates. To be fair, actually, I don't think you need to. Just make sure, if it did ask for the coordinates of intersection, you should leave it like that. But I have found the point of intersection anyway. All right, I'm hoping you're familiar with that. You'll practice one in a minute. If not, if you're really struggling, go back and practice. Find another video and practice some simultaneous equations, because this is like the starter for today, if I'm honest. Right, the second method is called substitution, and I want to talk about it because it's going to be substitution. It's going to be important in a bit. In this case, I would go with elimination, but being able to substitute is useful in certain circumstances. So I'm going to rewrite the equations. 2x plus 3y equals 8, but this time I'm going to go back to making y the subject of the second one. Y is equal to 3x minus 23. Because I'm finding where they intersect, my y values are the same, and I can actually replace this y here that I've just circled with this other y that I've circled, and I can write down 2x plus 3x minus 23 equals 8. Because, I'm just going to say that again, because I'm finding where they are the same value, then in that case, I can replace that y by that y, and hence this y by 3x minus 23. And we've essentially eliminated the unknown in a different way. We've got a little bit more to do, because we've got to expand this bracket. But you can see the same kind of numbers coming back. We're again going to get that 11x equals 77 just by rearranging this, and x equals 7, and y, if I put it back in the same, into the top one or the bottom one, I'm again going to get that y is equal to -2. So which is the easier method? Up to you to decide, really. But being able to master both is a good thing in maths. So try and be able to do both. I would say elimination is a little bit quicker, and I've chosen one where I don't get any fractions in. But if you made y the subject and you had fractions, that would be more awkward. Whereas you can avoid it with elimination because you're always making your numbers whole numbers. Right, I'd like you to try this one yourselves. Can you do it using elimination, and then secondly using substitution? Hopefully you've given this a go. I'm going to show you the answer. There you go. I chose one that didn't have nice whole number answers, because sometimes I find that people, they just try numbers out, or they have these other obscure methods to try and get the answer, but actually I want you to be able to do it in the most general way possible. So that's why I made the numbers not quite so nice. Right, let's do elimination. And again, sometimes you have to multiply both equations by something, but I've gone for ones here that you don't actually, because I wanted to keep y as just by itself. So what am I doing? I'm actually gonna multiply this top one through by 2. 6x plus 2y equals 2. Why have I done that? Because now the numbers are the same. These y numbers. By the way, you don't have to just eliminate the y's, the things in this. I could have multiplied this one by 4 and this one by 3 and then subtracted them. Just have an awareness of all the different things that we can do. This time I'm going to subtract them. So 6x minus 4x gives me 2x. These cancel. Same sign, so when I subtract them, they cancel. If they were both negatives, they would also cancel. And 2 minus 1 is equal to 3, which gives me x equals 1.5. Substitute back in. I think I'll put it back into the top one. 3 times 1.5 is 4.5 equals 1. So y is going to equal minus 3.5. Let's do it using substitution. So, and by the way, like I said, if there was like a 7 here, substitution is just not going to be very nice. You're going to get a fraction going on, but it does work well here. Y is equal to 1 minus 3x. Substitute that into this one. 4x plus 2, 1 minus 3x equals minus 1. We're going to get minus 2x equals minus 3, which again gives x equals 1.5. And from that, y will be 3 minus 3.5. Hoping you're happy with that. There's one more thing I just want to show you, because if you have a class with calculator, it can actually do all of this for you. That's not to say you shouldn't master this kind of equation. It's important. I just wanted to mention it. So actually, this equation's functions button is amazing because you can solve all sorts of polynomials, but you can also solve simultaneous equations. You can even solve simultaneous equations with more than 2 unknowns. However, they have to be these linear ones. We're going to look at quadratic simultaneous equations in a minute, and the calculator won't do that. So you can just press 2, get to this, and we can type it in. 3x plus 1y is equal to 1. This is a good way of checking your answer. Remember, there are questions that say like show all your working, and you will be expected. You can't just stick it in your calculator. So I'm just helping you out with regards to both. What I'm trying to. Okay, we put it in. X is 3.3 over 2, 1.5. Press equals, and y is minus 3.5. So have that there as well to check your answers to simultaneous equations. But practice both these methods and try to master them. onwards, because today we also want to cover, is this ambitious? I hope not too ambitious, quadratic simultaneous equations. These are equations with two or more unknowns, where you don't just have a y and an x with some coefficients, you might have an x squared in there, or a y squared, or both, or x times y, and so on. It can be, we're just building up the complexity of the maths, which could be useful in different situations or just of general interest. So let's do this then. How can we have a go at these two? Can you sketch this function here and this function here? Have a go. Right, well, y equals x plus 6 is already in the form y equals mx plus c, so it's going to be a nice sort of diagonal gradient like this, if I'm assuming it's to scale roughly, and I can label that as 6. Now if I draw y equals 2x squared, it's going to be very much like y equals x squared. It's going to go through the origin, those are the roots. That's the turning point as well. If you think back to completing a square, it's actually in completed square form technically. And it's going to come down and be a nice parabola that goes through the origin. And we can see that there are 2 points of intersection. So that will be not always the case, but you can get 2 solutions for quadratic simultaneous equations. How can we calculate the points of intersection here? Well, elimination, this method where we sort of add and subtract, actually in this particular case can work because we can cancel out the y's, but in general it won't always work. So my advice, where possible, is actually to use the second method of substitution. In this case, because I've got y on the left hand side here and here, I can literally just replace that y by the 2x squared, or that y by x plus 6, which I'm going to do, and write this down. Essentially, I've set them equal to one another. And I've created a quadratic now, just like we created a linear equation before. Now we've got a quadratic. So it's going to be 2x squared minus x minus 6 equals 0. And we're back to factorizing and solving quadratics. Of course, there are 3 ways that you could solve this quadratic. You could use the quadratic formula. You could complete the square, which, remember, the quadratic formula comes from that. Or you could factorize it. All the ones today that I'm going to put in this lesson are going to factorize. So it's up to you. But I kind of think it's good to continue to practice factorizing. It's got to be 2x and x. Then it's got to be, I could try 2 and 3. That's not going to work because I'd get 6x and 2x. So no, let's reject that one. 3 and 2, I'm going to get 4x. I'm going to get, this is going to work. So I'm doing cross multiplication just in my head. 2x times 2 is 4x. 3 times x is 3x. I can make it minus x if I make this one minus and this one plus. And that will multiply to give the minus 6. So x is equal to 2x is 3. 2x is going to equal minus 3. So x is going to be minus 3 over 2. Doing this quite quickly, but this is like practice of things we've done previously. Or 2. Now, I don't like to just say y equals, or I like to kind of link them together. So when x equals minus 3 over 2, substituting it back in, y will equal minus 3 over 2 plus 6. That's minus 1.5. So we're going to get 4.5, which is 9 over 2. Okay, you can do this on the calculator. You can leave it as a mixed number if you want. And when x equals 2, that one's actually easier. Y is just going to equal 8. I've substituted it back into this one because it's just adding 6 is much easier than squaring your number and then timing by 2. But of course, again, you could check it. You could use a quadratic formula on your calculator to solve this. All these things are possible. Just make sure that you try and master as much of this as possible. And here's the exact value. You can see we get 2 and 8. And it's a bit harder to see, but this is minus 1.5 and 4.5. Brilliant. My sketch wasn't bad, considering all things I had my axes up here with. Okay. All right, and that is the main idea, really. There's a little bit more to say, but the main concept of quadratic simultaneous equations has been covered. So in general, we can replace y or x in one equation by y or x in the other. So I'm now going to start you off with this one. I'm going to ask you to finish it. I mean, obviously I'll go through it, but I want you to try to do as much as you can by yourselves. So solve the following simultaneous equations. These are all ones now with squares in, and you can see here we've got an x squared and a y squared. So what is a good idea to do? Do we eliminate the y or do we eliminate the x? It's really up to you. And I'm just gonna make x the subject of this one. I think we could have made y the subject and y equals x squared minus 15, but then I'd have to substitute that into here. I don't know which is easiest. Okay, I think I will actually. I'll make y the subject of the bottom one. So y is equal to x squared minus 15. Because actually, I think this is going to be nicer because I was considering making x the subject of this one and substitute into here, but then I've got a double bracket to deal with. Whereas actually here, it's going to be easier. I'm just going to replace this y by this y here, and hence x plus 3. And like just practicing and getting better at this is, it'll just make you solve these things quicker if you spot an easier way to do it. So x plus 3 lots of x squared minus 15 is equal to 7, and I've used substitution, but I've managed to get rid of the y. So x plus 3x squared minus 45 equals 7. There's no issue there, is there? So 3x squared plus x minus 52 is equal to 0. This should factorize again. I said it would. So hopefully I'm correct. Of course, you can use a quadratic formula. So let's give it a go. So it's got to be 3x and then x. Oof, factors of 52 now. All right, I'm just going to write them down. So 1 and 52 is going to be way too big, so I'm going to rule that one out. 2 and 26 isn't going to work. 4 and 13. Maybe if I put the 4 there and the 13 there, because then I get 12 and I get 13, so that will work. Okay, so it's just a process of thinking about it. And then I need plus x. I need to make this plus and this minus. 3x plus 13, x minus 4. So x equals minus 13 over 3 or 4. Bit trickier to work out why, but we can do it when x equals minus 13 over 3, y equals, and I'm definitely going to use my calculator for this now. So remember, y is x squared minus 15. So if I write down minus 13 over 3, I'm just going to press equals, then square it. That means I don't have to put brackets around it. And then what was I doing? I was minusing 15. I'm going to get 34 over 9. And then when x is equal to 4, that one should be a bit easier to do. Because I can see that's going to be 16 minus 15, y is going to equal 1. So we get one really nice answer with integers, one with fractions. I hope you're happy with that. This technically is something that could come up at GCSE, as is the next one. So it is practice of that, but if it might have been a while. I hope everything I've said makes sense. Try this next one out yourselves. So actually, if this is already set up really well, we've got an x squared and a y squared here. So I don't want to make one of these, the subject. I don't want to try and take square roots. Remember, actually, I just want to bring back this. You cannot square root this, and square root this. That just doesn't make any sense. You have to put square root thing around the whole thing anyway. You don't want to do that. Just substitute directly in for y, I would. So x squared, hold on, what did I say? Oh yeah, x squared plus x plus 1 all squared equals 1. Now just remember, this is a double bracket. So we're going to get, let me just slow it down and put the whole thing in. It's this. The more practice you do, you can just multiply double brackets in your head, but for now I'm taking it steady. So I'm going to get x squared, I'm going to get a plus x and another plus x, and then a plus 1. That's going to leave me 2x squared plus 2x equals 0. Interesting. And actually I'd probably divide through by 2. Factorize out the x. X equals 0. Don't forget about that one. Or minus 1. When x equals 0, y is going to equal 1. And when x is equal to minus 1, y is going to be 0. Getting interesting two solutions there. Don't forget, or maybe you've never covered this equation before, so I say don't forget, but it all depends. This is the equation of a straight line. The other one is the equation of a circle centered at the origin with radius 1. So we've basically just, what have we done? I think we've actually found this line here just goes for it twice. I probably should exaggerate my circle a bit more like that. So we got this point here, what we found, and this point. Let's try it again. This point here and this point here that we've just found. Right, let's increase the complexity now. It's the same process though. Just think carefully about which one to substitute in for. Give these a go if you're feeling all right about it. Otherwise, I'll go through them. First one then, y equals 3 minus 2x. It makes sense to substitute in for y because otherwise I'd get fractions. Then it's going to be 2x squared minus x, 3 minus 2x. I would argue that this one's actually, it looks more complicated, but it's probably easier than the last one. We're just substituting in for that single y, and it's not a y squared now. The only thing we need to be careful of is that double negative, so I'm going to get minus 3x, then I'm going to get another plus 2x squared. This leaves me with 4x squared minus 3x minus 10 equals 0. Okay, it might be 2x and 2x, or it might be 4x and x. Actually, because there's a minus 3x here, it can't be 2x and 2x because there's no way I'd get an odd number here. So we've just got to try some things out. I think I was going to try 5 and 2. That's not going to work. Just this one's a bit trickier actually, unless I've made a mistake. Okay, I see it. So okay, so you could try 1 and 10. That's going to be way too big. You could try 10 and 1. No, this isn't going to work. 5. There's no way I get an odd number there. So the only thing could be is 5 here and 2 here. And that will give me 8x, and I'll get 5x. So that will give me the minus 3x if I make this minus 2 and this one plus 5. Don't forget it equals 0. So x is going to equal minus 5 over 4 or 2. And when x is equal to minus 5 over 4, y will equal, and I'm going to substitute it back into this one here. 3 minus 2 times minus 5 over 4. (11 over 2). This one is going to be 3 minus 4, so it's going to be minus 1. Okay, we're done. We've solved another one. All right, the last one. This is the sneakiest one. Think carefully about this one. So if you wanted to substitute it for y, you'd have to get a fraction in there, which is not very nice. But what we can actually do in this case is recognize that this bottom equation is none other than 2x all squared plus 2xy equals 21. And we can actually just substitute in 2x directly. 2x is equal to 5 minus 3y. Wow, so we can write down that 5 minus 3y all squared plus 5 minus 3y y is equal to 21. And I've managed to eliminate or get rid of x. I'm careful of using the word eliminate because we're using substitution here. I have eliminated x, and now I've got a quadratic in y that we've got to sort out. Okay, this is a double bracket, so I'm going to get 9y squared from that minus 3y times minus 3y. I'm going to get minus 15y and then another minus 15y, so I'll get minus 30y, and I'll get a plus 25. From here, I'll get 5y minus 3y squared, and I haven't quite managed to fit it in, but that's going to equal 21. Tidy this up. I'm going to get 6y squared minus 25y plus 4 equals 0. Another quadratic that doesn't look particularly nice to try to factorize. So is it going to be 6y and y, or is it going to be 3y and 2y? I just don't know. It's quite a large number here, so but I've got a 4. So they're both going to be negative. That's the thing. All right, well, let's just go with it. I can't remember the answer. Let's try 6y and y. The nice thing is that this is a smallish number. So I think I see it actually, because if I put in a minus 4 here and a minus 1 here, I'll get minus 24 and I'll get minus 1y. So that's all going to be good. Y is equal to 1/6 or 4. When y equals 1/6, x is going to equal, and then what do I substitute back into? Well, I'm going to have to then rearrange this and divide by 2. So it's going to be 5 minus 3y over 2. So this is just more technical, more chances of making mistakes, but it is the same process. 9 over 4. And when y is equal to 4, we're going to do 5 minus 12, which is minus 7 over 2. I think we're going to get minus 3.5 or minus 7 over 2. I'm just going to check that. Okay, brilliant. All right, so I know there's quite a lot going on today. Looking at this and then linear equations, just recapping them, talking about two methods, bringing back simultaneous equations with quadratics. If you've struggled, then there's other videos that go at slightly slower pace, but your ultimate aim is to be able to deal with the last two. Okay, this is quite a standard A-level question, I'd say. This is a harder A-level question, let's be honest, but try and make sure you've mastered both. Well done on your efforts. Get practicing some more. Okay, keep it up.